Okay, we can easily figure out how many possible rolls we have with 2 dice by using our odometer method. So with dice 1, we have a possibility of 6 different rolls. We got 1, 2, 3, 4, 5, or 6. Same with dice 2. I'm just going to call that D2. We have a possibility of 6 rolls. 6 times 6 gives me 36 possible options. And if we look up or open up our, I want my sticker there. There you go. If we open up our dice here, we have an example of, we could count up, we have 36 possible rolls. So we're going to look at what is the probability of rolling a 2. So we can go up here, and the only option would be the 1 out of 1. That's the only probability of rolling a 2. So our probability of rolling a 2 is 1 out of 36. Okay, then what's our probability of rolling a 7? So let me erase this here. And our probability of rolling a 7. So if we look at this, we could roll a 6 and a 1. We could roll a 6 and a 1 this way. So we've got those two. We can also roll a 5 and a 2, and a 5 and a 2. Notice there's a pattern here in my madness here, a 4 and a 3, and a 4 and a 3. Those are our different possible ways that we could roll a 7. So we have 1, 2, 3, 4, 5, 6 different ways. So our probability of rolling 7 is 6 out of 36, which is 1 out of 6. Okay, and we want to know the probability of rolling a less than 3. So, same concept, except we want to roll less than 3. Since it's less than 3, 3 is not included. So let me get my pen again here. So less than 3, we can roll a 1, 1, but a 2 and 1 is going to actually give us 3. Same with 2 and 1. So 1, 1 is the only row we could have that is less than 3. So we've got a 1 out of 36 probability. Okay, which should be the same as our A probability, because the only thing less than rolling a 3 is rolling a 2. So if we continue on with that, we can also look at the complement of these. And the complement is basically all of outcomes that are not in the sample. So our E represents our event. So these 3 up here are our E probabilities. Our E is 1 out of 36, our E is 1/6, and our E is 1 out of 36. That represents the probability that an event occurs. Our complement of that event is the probability that everything else occurs except for that exact probability. So if we add up our probability and our complement of that probability, we should get 1 or 100%. So if we look at part A, well, obviously part A and C are going to be exactly the same, but we know that we have a 1 out of 36 chance of rolling a 2, so our complement, or our E prime, is going to be 1 minus 1 out of 36, because it's the probability of not rolling a 2. And if we look, we would cross that off, and then we would add up everything else, which would give us 35 out of 36. That would be our complement to part A. Let's try our complement to part B here. Okay, we could do it a couple different ways. We could cross out all the 7s if we did that. We physically went over and crossed out everything that equals 7. Okay, our complement would be what is left over, which if we added all of those up, we would get 30 out of 36, or 5 out of 6. And if we add up our 5, 6 plus 1, 6, we should get 1. So if we add up our E, which is our probability, and our E complement, or E prime, we should get 1. And then again, our A and C should give us the same probability. So if we subtract that, our E complement is going to be 35 out of 36. So our complement is anything that does not occur in our original probability.